Hello everyone, and thank you for attending today's webcast, New Category of Blast Abrasives from 10X Engineered Materials. My name is Stephanie Chiswick, and I'm Editor-in-Chief of CoatingsPro magazine. 10X Engineered Materials is introducing a new category of abrasive blasting media made of ultra-safe, ultra-strong mineral alloy particles. In this webcast, their experts will explain how the particles are formed into a unique material matrix that yields breakthrough speed and surface quality with no health or environmental risks, including no free silica and no beryllium. Before we begin, we wanted to cover a few housekeeping items. At the bottom of your audience console are multiple application widgets you can use. If you have any questions during the webcast, you can click on the Q&A widget at the bottom and submit your question. The presenter will answer as many questions as he can at the end of the webcast and will respond to all remaining questions via email. We do capture all questions. Additional materials are available in the resource list widget that looks like a green folder at the bottom of your screen. You can expand your slide area by clicking on the maximize icon on the top right of the slide area or by dragging the bottom right corner of the slide area. If you have any technical difficulties, please click on the Help widget. It is a question mark icon and covers common technical issues. An on-demand version of this webcast will be available in about 24 hours and can be accessed using the same audience link that was sent to you earlier. Without further delay, I'd like to introduce our presenter, Dr. Stephen Ritchie, PhD. Dr. Stephen Ritchie is the Chief Technology Officer and inventor of the 10X process. He is the former Director of Clean Technology Research, Development, and Commercialization at Battelle Memorial Institute. Dr. Ritchie has expertise in fluid, energy, and material sciences, technologies, and associated business strategies. With that, I'll turn the presentation over to Dr. Ritchie.
Thank you, Stephanie, and good afternoon, everyone. I want to first thank NACE for the opportunity to present today. And thank you to everyone who's joined us. As Stephanie said, my name is Steve Ritchie. I'm the Chief Technology Officer at 10X Engineered Materials. This webinar is about an abrasive blast media that we introduced just over a year ago. It's now CARB approved and certified to meet or exceed the requirements of SSPC AB1 for non-metallic abrasives. The abrasive has continued to surprise us with what it can do. My partners and I have been in the technology development business for almost 30 years now, and we knew early on that this one was special. It's a breakthrough that had to be commercialized. We've defined a new abrasive category that encapsulates and helps to succinctly explain the unique attributes of the abrasive and will hopefully create a whole new avenue for progress in the abrasives industry. We're also excited to announce two new product lines that will allow users of abrasives and applications from high production maintenance work to specialty manufacturing to benefit from this new material. .10X was formed by a group of engineers and scientists that spent their careers conceiving new ideas and commercializing new technologies to improve things. Our core values revolve around innovation, performance improvement, safety, and sustainability. The first thing we did very early on in development, and even before we had a pilot facility, was test the material for metals and free silica because we didn't want to develop a product that could cause harm to people or the environment. Of all the things that we want to share with you today, this is the most important. 10X abrasives are safe. We routinely test samples of the products for crystalline silica, beryllium, and leachable metals. The TCLP is clean. Free silica has never been detected using NIOSH 7500 at a reporting limit of 0.1%, and beryllium has never been detected using EPA 1311 at a reporting limit of under 4 parts per million. And finally, people often ask us where we got the name 10X Engineered Materials. In our world of new technology development, 10X is a holy grail of sorts for quantum leap improvement that innovators aspire to. So we named the company in that spirit of striving for truly disruptive positive impact. Ten-X abrasives are made from a mineral melt that is rapidly cooled into a solid. This does several important things in a blast abrasive where the objective is to quickly and safely produce a quality surface ready for coating or use. First, it creates a completely amorphous particle matrix, which means that there are no crystals in the material at all. X-ray diffraction scans confirm this. It tempers and toughens the particles, enabling them to deliver more of their energy to a surface than other abrasives, even harder and sharper abrasives, which we'll talk more about. It makes the particles uniformly strong. There are no pores or fracture planes where the particles will tend to break, embed, or form dust. And the shape of the particles is unique. There are sharp particles and rounded particles and everything in between. And all of this adds up to an abrasive that's fundamentally different from what has been on the market for the past several decades. It's completely safe for workers, low dust, exceptionally productive, and leaves a pristine finish on metal surfaces. We'll show you how it delays rust bloom and improves coating and bonding performance. We have had so many people ask us, what is this stuff? And then we'd start in on how it's made, how the particles are stronger, how they deliver more energy, how they don't embed or initiate rust bloom, and so on. We decided that we needed to name this category of abrasives. Since there is no existing word or scientific term that would accurately describe it, we borrowed from metallurgy and mineralogy and constructed a new scientific term, superoxalloy. It's a composite of the terms alloy, superalloy, and oxide. A superoxalloy is an alloy of mineral oxides that is formulated and processed to be extra strong and have superior properties compared to conventional mineral abrasives. Superoxalloy goes a long way in answering that question, what is this stuff, in one new scientific term. So most mineral abrasives in the surface preparation industry today are formed in an uncontrolled environment. For example, mined abrasives are formed in the Earth's crust over millions of years, which means you get what Mother Nature produced, and that varies from location to location. They often contain crystals like quartz on varying scales and have unavoidable pores and weak planes that can result in particle fracture when a strong force is applied. So what's different about a superoxalloy? First, it's formulated and manufactured in a controlled process. The mineral mixture and processing conditions are selected for material strength and performance, but also health and safety. It's amorphous. There is no long-range molecular order, which eliminates fracture planes and makes the particles uniformly strong in all directions. Rapid cooling of the melt also tempers and further strengthens the particles. Amorphous also means that there's no crystalline free silica. We routinely have third-party labs do controlled testing on samples of the abrasive, which is the gold scientific standard for determining whether a material can possibly create an environment that exceeds exposure limits for respirable free silica, beryllium, or any other hazardous substance. There's a misconception in the industry that air monitoring in a blasting environment provides a controlled measure of silica or beryllium in an abrasive, and it does not. Air sampling is not controlled for the substance being analyzed, which is a scientific requirement. However, when done correctly, air monitoring is certainly effective for measuring the level of a target substance in a work environment. But the abrasive is only one of several potential sources. So in a blasting environment, air is being expelled from a nozzle at over 400 miles an hour, and stirring up the tiniest respirable particles from the ground and other surfaces. There may be leftover abrasive materials in the pot, in the hose, or in other places in the space being monitored. The point is that there's really no sound scientific way to attribute what is detected on an air sample to any individual potential source except the entire space being monitored. Each potential source would need to be analyzed to eliminate that uncertainty. So the only sound scientific ways of measuring the level of a hazardous substance in an abrasive is to either 1, collect the air samples in a perfectly clean space with clean equipment to remove the other potential sources of the target substance, or 2, through regular scientifically controlled testing of uncontaminated samples over time, which is what we do at 10X. And finally, superoxalloy abrasives just leave a beautiful surface finish. It leaves a bright SP5 finish on metal with little to no embedment or residues left behind. Customers who measure coating quality and adhesion are reporting significant improvements. And a clean surface also delays rust bloom, which we will show later in the presentation. So over the past 18 months, we've been seeing results that left us scratching our heads. One is a constant and significant combination of faster blasting and lower abrasive consumption compared to abrasives in other categories. Another is the ability to quickly remove extremely difficult coatings that even harder and sharper abrasives can't remove. Some examples include Viscotac pipe wrap and multiple layers of baked and hardened powder coat. Another interesting attribute is the relationship between blasting speed and nozzle pressure appears to be unique with our abrasives. The performance of the abrasives continues to improve as pressure is increased to 120 psi and even to higher pressures. It's common to see the performance of abrasives level off or even decline at these higher pressures. We encourage our customers to get the pressure up if they can because the material just comes alive and the results can be amazing. Getting our minds around this as scientists and engineers is what led us to the superoxalloy category. The short story is that blasting at its core is an energy transfer process. We invest in compressors and fuel to accelerate particles to a high energy state with the objective of delivering that energy to a surface as efficiently as possible. But when a particle breaks on impact with a surface, no matter how hard the particle is, a significant portion of that particle's energy is lost to the break. It's the same reason that a baseball doesn't go very far when the bat breaks. The energy of the bat and ball were used up in breaking the bat. Because a smaller fraction of superoxalloy particles break on impact, we've been able to show that it can outperform a harder abrasive that does break. This is also why 10X abrasives produce less dust, decrease embedment, and leave a cleaner finish. And if you look closely at the particles, you'll see a unique shape distribution that includes the whole spectrum of particle shapes, from sharp to rounded. And this diversity of shapes enables the abrasive to achieve a variety of surface prep objectives and makes it very flowable. It can be delivered smoothly through a metering valve at very low settings. And it's also very effective in wet blasting because it flows well and it doesn't plug lines. So we are very excited today to formally and publicly introduce 2 new abrasive product lines. Kinetics is essentially the products we've been selling for the past year. It's comprised of our coarser grades for use in high production, larger scale blasting jobs. EpiX is our finer fractions that have proven to produce tremendous value in more specialized fabrication, device and equipment manufacturing, and their associated coatings applications. Kinetics means high energy delivery. Kinetics is the product line for large production jobs like shipyards, bridges, tanks, and rail that involve thicker coatings and require deeper profiles. In these applications, the blasting process can dramatically affect the overall economics. Not only is kinetics faster, but it also minimizes the massive cost of assets being out of service because of rust bloom, coating quality issues, or the time and cost of rework. Kinetics is also reusable in reclaim systems and poses no harm to people in the environment, which we've discussed. Kinetics comes in 4 mesh size ranges. The coarser 1020 and 2040 are better in applications where thick coatings are being removed and replaced and a deeper anchor profile is needed. 2070 and 4070 are fantastic all-purpose abrasives for that 2 to 3.5 mil profile and removal of everything from mil scale to thick and hard coatings. Kinetics products are available in 50-pound bags, 1 and 2 ton super sacks, or by bulk truck. So we discussed earlier how superoxalloy abrasives are able to do things that other abrasives can't. And we're illustrating that point here with 2 examples, but there are many more. The picture on the left is of a paint rack with about a 1/4 inch of multiple coating layers that the contractor said could not be removed with any abrasive in his shop. Kinetics 2040 removed it immediately and left a clean and profiled finish. And we're seeing the same thing on ship cladding, tank liners, and other similar applications. On the right is where we began to understand how and why our abrasives delay rust bloom. The picture shows a 4x8 steel panel blasted in sections with copper slag, garnet, and Kinetics 2070. The objective was to compare speed and profile, but the panel was left in the yard. The owner of the yard noticed on day 2 that the copper slag and garnet sections had started rusting and the 10X section had not. It then rained overnight from day 2 to day 3, and there was still no sign of rust. And it turns out that rusting of bare metal is an inherently slow process. It can only happen quickly if there are iron or water-soluble salt residues left behind with embedded particles to initiate and accelerate the corrosion reactions. Rust bloom is delayed with 10X abrasives because they leave a clean, bare steel finish. Our shipyard customers are noticing. Just recently we had a section of a ship that was blasted to an SP6 finish and then had to sit before being recoated, and after 3 weeks it was still SP6. So EpiX means epic. It's an awesome set of products. EpiX can replace and outperform exotic abrasives like aluminum oxide, silicon carbide, and ceramics, but at a much lower cost. EpiX is a product line for applications where surface quality, cleanliness, precision, appearance, and reusability of the abrasive are at a premium. Like the Kinetics grades, EpiX is fast and effective on the most difficult coatings. We're working with several powder coat customers to eliminate burn-off ovens and chemical stripping because they're no longer needed. But what we're finding in these markets is that cleanliness, surface quality, and reusability are the drivers in device manufacturing and specialty coatings applications. And EpiX is highly recyclable. We have customers who are getting more than 12 uses. EpiX comes in 3 grades. EP stands for Enhanced Profile, MP is Medium Profile, and LP is Low Profile. And EpiX is also available in 50-pound bags, 1 and 2 ton super sacks, or by bulk truck. So the field cases that we're going to show you illustrate how superoxalloy abrasives can outperform harder, sharper, and more expensive abrasives. These are some of the results that truly had us scratching our heads for an explanation. The picture on the left is of a hanger hook used to hold powder-coated parts as they are cured in the oven. The hooks had multiple layers of baked-on powder coat that was barely dented by aluminum oxide after 2.5 minutes. EpiX MP was able to completely clean one side of a hook in about 20 seconds and leave an SP5 finish. The picture on the right is of a lid with a primer layer and a powder top coat. The shop was pleasantly surprised at the level of control they had when blasting this part with EpiX LP, our low-profile product. They could decide whether to remove only the top coat or to blast the bare metal by adjusting the nozzle distance. And this final case study encapsulates everything that we've been discussing in this webinar. It shows the quantum leap improvements in quality and economics that are possible with superoxalloy abrasives. The pictures on the right show a tungsten carbide asphalt milling and removal bit that is used to break up and remove asphalt from roads and highways. The manufacturing process involved first tumble blasting the tips for 30 to 60 minutes using silicon carbide, cleaning the underside of the tip with flux cleaning agent, and then braze bonding the tip to the base of the bit. The brazed bond in many of these parts would fail at well under 8,000 psi in a test press. With EpiX EP, the blasting time was reduced to 10 minutes, and the underside of the tip was clean and ready to bond without flux. When the part was tested for strength, the tungsten carbide cracked at 18,000 psi before the bond failed. So using EpiX on this job resulted in a 67% reduction in surface prep time, elimination of a cleaning step, and a 125% increase in part strength compared to silicon carbide, which is among the hardest and most expensive abrasives available. Now, we would love the opportunity to help everyone on this call experience this breakthrough. When it's set up and used properly, it is truly remarkable. And I'd like to share a quick story with you. We have a new customer who called us out of the blue because he saw one of his competitors complete a job in 7 days that he usually bids 25 days for. And he told us that he saw 10X on the site and had to call because he couldn't let his competitor take his business. Kinetics and EpiX superoxalloy abrasives will keep your workplace and workers safer and healthier. They will enable you to do the hardest jobs faster. They'll decrease or eliminate your dust headaches. They will minimize rust bloom, rework, and get assets back in service faster and with higher quality. And now we have product grades for everyone, from the high volume blasters to equipment and specialty device manufacturers. So I want to say again, we greatly appreciate the opportunity to speak to you today, and we look forward to working with you in the near future. Before we start to answer questions, I'm going to hand it over to my partner, Jake Valancourt, to say a few words.
Hey, thank you, Steve. That was a wonderful presentation. My name is Jake Valancourt. I'm a partner with 10X, and I wanted to thank everybody for logging on to view our presentation today. We have a couple items to share before we actually dive into the questions, and we have a lot of questions. So please stand by, keep the questions coming. First, as a real true thank you to our new to us and new prospects and customers, we want to offer that if you order a full pallet or more of any of the 10X EpiX products within the next 48 hours for delivery within the continental United States, we'll give you totally free shipping. This offer is valid only through 10X and authorized 10X distributors. Contact us directly with questions on that. And additionally, tomorrow morning there's going to be a live, socially distanced outdoor demonstration of 10X Superoxalloy at the Plaquemine Point Shipyard, which is right outside of Baton Rouge, Louisiana. This is courtesy of Cleaner Blast. You can reach out to 10X or Cleaner Blast if you would like to participate. Again, that's tomorrow morning in the Plaquemine Point Shipyard right outside of Baton Rouge, Louisiana. So thank you, everybody. Now we'll get to the question and answers. So the first question, let me just scroll up here, Steve. First question we have is actually somebody asking about clearing up that there are no environmental concerns with the product. So I think we should talk a little bit about CARB, and then go right from there, and I'll pull in the next question after that, Steve.
Okay. Yes, there are no environmental concerns. We, as we mentioned, we've passed CARB certification, which is the California Air Resources Board, and we are now not just compliant with SSPC AB1, but we're certified. But if you look at the TCLP, and specifically the total threshold limit concentration, which is in the solid, in the material, and the soluble threshold limit concentration, which is the wet test for leaching of metals. The only three on the expanded test, the only three metals that even show up are barium, vanadium, and zinc. And they are at least 50 times below the regulated limit, the EPA limit for these materials. So they're only in there in trace amounts, and every other metal that's tested for, including mercury, beryllium, arsenic, the whole list, were not detected in the and have never been detected in samples of our material.
Thank you, Steve. And just to be clear, they're actually asking also about containment. And I'll add that anytime you're blasting, doing lead abatement, if you're dry blasting and not using some sort of wet or vapor blasting, you're going to need containment. But outside of that, what can we say about containment needs?
It's going to depend on a lot of things. Whether or not the containment requirements would change is going to depend more than on just the abrasive. But I will tell you that it's possible. But, for example, containment and routine, ES&H monitoring of a work site, still has to happen. You still need to be done even if your abrasive's clean, because there's other materials in your environment.
Thank you, Steve. So we got a couple of questions. We have one from Blast One. I see Thomas Industrial. I apologize, it's not showing the full name there. Essentially asking for a cost comparison of price per ton versus coal slag products. And I'd just like to start with price per ton doesn't matter. Frankly, what matters is a cost per square foot, and 10X has a massive advantage there. In the past few months, we've converted an entire shipyard from a slag product to 10X, and they have gained significant improvements, including the rust delay. And leading off from that, Steve, I'll throw into this line of questioning. There's another question, and it doesn't actually say the company name, which is interesting, but essentially they're asking, how does the rust delay work, and is there additive chemistry in 10X, which I thought we covered, but because the question came up, I wanted to have you recover that, Steve, on the additive chemistry and the rust delay features.
Sure. Yep. Our process uses no chemicals at all. So we don't add anything. It is just the abrasive. And the reason that it delays rust bloom is really an embedment issue. Because it's minimal to no embedment. We had a major oil company do a study of several abrasives for embedment, and our abrasive was included in that. And what they found was that they didn't find any. It was the only abrasive for which they found no embedment. I can't promise you that there won't ever be an embedded particle, but it's really low, if not zero. And that's where rust bloom starts. So a particle gets embedded in the surface, it sticks. If it has iron content, if it has soluble salts, which most materials do, then rusting will be initiated around that particle, and it will grow from there in hours, sometimes even minutes if it's a really humid environment. But that's how rust bloom starts and propagates. And with 10X abrasives, since the process can't get started, it's left to corrode at the natural rate of bare steel, which is really slow.
Thank you, Steve. We have a couple of questions on the T-clip. A couple of people have asked similar questions. How does our T-clip results compare to other abrasives on the market, specifically slags? And just an additional question here where it's actually about performance. So go ahead, Steve. I'll wait for the answer on the T-clip.
So on the T-clip, I actually don't have like a slag T-clip in front of me, but I do know that there are materials like arsenic in some slag materials. There are, among other leachable metals. The only thing I can tell you with certainty is that many of those materials, or virtually all of those materials, are either barely detected or not detected at all. Like I said, the only metals that are detectable in samples of 10X are arsenic, vanadium, and zinc, and they're at trace levels. Nowhere near the EPA limit for leachable metals.
Sure. We have a question from Saudi Aramco that's asking if we have comparative performance in terms of conventional abrasives versus 10X's superoxalloys, and I think that we do, and they're also asking if this could be returned, reused, essentially. Can the abrasive be reused? And yes, it can. Steve, do you want to talk a little bit about the comparison to conventional abrasives and what we see on efficiencies and dust?
Yeah, we do. We have quite a bit of data. We have data where we were compared head-to-head with, copper slag, coal slag, aluminum oxide, garnet, and we do have this data. What we find generally is that the consumption of an abrasive, if you strip a particular coating of a known area, something that you can time and measure how much abrasive you used, when we're able to accomplish those three things, we routinely find that the pounds per square foot required is lower, in many cases significantly lower, and that the speed in square foot per hour is higher. And when you add those two together, when you put those two together and you do a cost analysis of a job, revenue can increase. If you're going faster, you can do more work, and you make more money because you can do more square feet. So there's a revenue impact. But then, the time-based efficiency, which would be blasting speed, that lowers your fuel costs per square foot. That lowers your labor costs per square foot. And then if you look at consumption, if the consumption is lower, then your weight-based costs, like the cost of disposal of the abrasive, the time that a pot lasts, so your lost time in pot changes, all decrease. And then when you combine those two and you look at overall cost per square foot, the superoxalloy abrasives can be cheaper than even a slag abrasive on a cost per square foot basis because of that. And what was the second part of the question?
I think we've addressed it, Steve. We've got some other questions we've got to get to here. So
okay.
One customer is asking, actually, a rep from PPG. PPG is one of the global distributors of 10X, and they're asking, can this be used in standard blast pots? And that's an easy question to answer. Yes, And while we're on that topic, someone else asked if it can be used in vapor blasting, and tomorrow's demo will show that 10X works well in vapor blasting equipment. Cleaner Blast and Greener Blast have both used it, and I think that Graco with their EcoQuip units have used it, as well as Schmidt. So a lot of the big brands out there are already using 10X in that type of blast technology. And then we also have a question, if you can use 10X on stainless steel. Yes, absolutely. You can use 10X on stainless steel, mild carbon steel. Steve, you want to talk a little bit about how everything's an oxide and how that's a pretty cool benefit?
Yeah, so there is a little bit of iron oxide in the mineral matrix, but iron oxide is not a danger to stainless steel. It's the free iron that's a danger to stainless steel, and there's no free iron in our abrasive. So yes, you can blast on stainless steel, and it has been blasted on stainless steel with no problems.
All right, and somebody's asking about the, I think this question is essentially asking the density. What is the density of 10X's EpiX products?
Yep, the density of the material itself is 2.6 to 2.8. That's specific gravity, or grams per centimeter cubed. The bulk density of our EpiX products is between 105 and 110 pounds per cubic foot.
All right, thank you, Steve. And we got another question here asking, what is 10X made of, and why is the consumption of 10X lower than other types of abrasives that are not superoxalloys?
Okay. First, the mixture of minerals that's in 10X abrasives is about 40% silicon dioxide, amorphous silicon dioxide, not crystalline. There's calcium oxide, magnesium oxide, and then there's aluminum oxide at a 10 to 13%, and then a small amount of iron oxide, 1% or less. And the second part of the question was about consumption. So this is a very good question, and there's not one answer. It's a combination of things. The first one is all about the energy delivery. So if, let's just say you have a pot of, which is a certain volume. Let's just say it's a 6 cubic foot pot, and you fill it with 10X abrasives, and then you fill a similar pot with a denser abrasive. So what's going to happen is you will have the same volume, same number of particles in those two pots, but far less weight in 10X with 10X abrasives because it's not as dense. And when you so you've paid less because you buy it by weight. You paid less to fill that pot. Then you blast those two pots out. If the 10X pot is more productive, if it blasts faster, your overall consumption in pounds per foot squared will be lower. So that's one effect. The other effect is the delivery of energy. When you blast with this superoxalloy abrasive, you'll see immediately that the dust is much lower than what you're accustomed to seeing. And the reason is that fewer particles are breaking. So if fewer particles are breaking when they hit the surface, then that means that a greater percentage of the energy that is in those particles when they leave the nozzle is being used. So more particles are doing more work. So you should then need less of it per square foot, which drives consumption down. And then there is a third, it's a minor point, but it's an important one. The material flows very well, through conduits and through valves. So when you use our abrasives, the metering valve on the pot needs to be dialed back. You know, if you're used to opening it up 4 to 6 turns for an abrasive, you're going to be at 2 to 3 turns open with our abrasive. And because it flows very well, it'll flow through that small opening in the valve, even when the valve's turned back. And that helps achieve lower consumption as well.
So we have a question. Is there a learning curve or special adjustment to blast equipment, or is it just a matter of adjusting material flow rates and ensuring adequate pressure? I think, you know, answering that broadly might be helpful, Steve.
So the answer is yes, but it doesn't usually involve any investments in additional equipment, or unless, for example, you don't have a valve that meters well. Some valves meter better than others. We try to make sure that our customers have a good metering valve. But having said that, it's generally just adapting the equipment to the material, and it only takes a few minutes. We can normally get the equipment set for 10X within 15 minutes. We do highly recommend that you get the pressure up. The benefit of the particles not breaking, you know, every material has a pressure threshold, where once you get above a certain pressure, the particles will start to shatter on impact, and the abrasive becomes less effective. And we're not seeing that happen with 10X. So if you can get the pressure up, it's just going to keep going faster. And in jobs where we can get that pressure up to 120 or maybe even higher, it's crazy. It's really fast. So that's a matter of compressor capacity and a number of other things. But that can also usually be accomplished with some adjustments to the equipment.
Thank you, Steve. There's another question. There's quite a few questions there. Keep rolling in. So everybody, good job. Keep them coming in. We're trying to prioritize them, and I'll just say in the middle here now, we're probably not going to be able to answer every question here. We've got over 80 right now, so we have a team working on prioritizing them. But if we don't answer your question, we promise we will get back to you and answer them after the webinar. I think the webinar cuts off just a little after 3. So with that, please, if you have a question, feel free to ask. We'll make sure to answer them, and we'll answer common questions that we're seeing online, and anything that doesn't get answered again will be answered offline. So don't hesitate to ask any questions. There is an interesting question here, which is about the wear on parts. And there's a customer who stated that they're having high wear after adopting garnet. Will they see similar or worse, even more wear rates on their consumables? I think they're talking about their nozzle, blast hoses, things like that. If you could just address that.
Yeah, that's a very good question. So you will see less wear in your equipment, and the reason is, you know, garnet is a sharper abrasive than 10X abrasives are. What we've found is that when our material is moving sort of parallel to a surface and eroding that surface, it erodes the surface more slowly than other abrasives. It's when that particle is going perpendicular to the surface where it can be, you know, nasty. That's where it can really impact and affect a coating and a surface. But when it's moving in parallel, it just does not erode as fast as many of the other abrasives, doesn't wear parts, because there's just not as much friction with the walls of the nozzle and the hose and so forth.
Sure, a quick shout
out. It's those rounded particles.
Sorry, Steve.
Go ahead, Jake. I'm sorry. No,
a quick shout out to... Go ahead.
No, I'm done.
Okay. All right, so quick shout out to George from MES. He's asking about recyclability, and we've got about 10 other people asking various questions about recyclability. So to try to hit them all, they're asking, is there any special equipment that you would need to be able to recycle 10X as compared to recycling garnet is a big question. There's some folks asking about also on recyclability, will the product begin embedding after reusing it as well? So just try to answer all of that in one if you could.
Yep. So let's talk about recyclability. So with our abrasive, one of the things that's not different about it is that the larger particles tend to break down more than the smaller particles do. As we told you, the EpiX grades, they are highly recyclable. Those are the smaller particles. Our 20 mesh particles, they break down at a rate of right around 50%. So you'll get maybe 2 uses out of that particle size. But as you get smaller, the breakdown rate goes down, and you can get 4 out of the 40 mesh size range, and then it goes up from there. So if you've got, say, our 2070 product or our 2040 product, there will be some breakdown, but what we find is that it doesn't break down into dust, it breaks down into a smaller particle that's still usable. So it's really just a matter of making sure in your reclaim system that you set the makeup that you keep getting a consistent profile. The more coarse the abrasive is, the more makeup you may need, but it's definitely reusable. You'll get 3, 4, even up to 6 reuses with the kinetics grades, depending on conditions. And with the EpiX, it's 6 and up. So that I answered the recyclability question. Oh, in reclaim systems. So if you're using a reclaim system on say garnet or anything that's more dense than 10X abrasives, and it has say an air wash in it to remove the dust before the material's put back in the pot, you're going to have to turn that down, that airflow down, because our material is not as dense, and if you keep it at the same airflow rate, it may blow viable product out into your dust collector. So that's the main adjustment that needs to be made, but that needs to be made in setting up a reclaim system for any abrasive.
Steve, while we're talking a little bit about density, somebody's asked a question that our specific gravity seems to be a disadvantage compared to garnet and Starolite. Could you speak just a little bit about that?
Yeah, so it is on the surface, because a heavier particle, two equally sized particles. You got a Starolite particle and you have a 10X particle, and the Starolite particle is the same size, going to be heavier. So it's going to have more momentum, more energy when it hits the surface. Well, maybe not energy, because there's another factor. The other factor is velocity. How fast is that Starolite particle coming out of the nozzle compared to the 10X particle? We don't know. We haven't measured this. We don't know this yet. But there's a chance that velocity is higher on the lighter particle. And if it is, then the energy that it has to deliver to the surface goes with velocity squared. So if it's going faster, it could overcome a mass disadvantage. But really what it comes down to is friability. Even if that 10X particle comes out of the nozzle with, say, less energy because it's lighter, if it doesn't break and the other abrasive does, then that 10X particle is going to do more work on that surface, even if it's less dense. And that is what we're seeing over and over and over again.
So we have a question, thank you, Steve, on PPE. Is it the same for other abrasives or any special PPE requirements? I can answer that. There's no additional PPE requirements. And Steve, if you could talk a little bit about being able to leave it on the ground and the sorts of benefits that people are seeing for environment, health, and safety. I know we touched upon it in the slides too.
Yeah. The only thing I do want to say is that they're not less either. while it's lower dust, it does create dust. It's impossible to avoid some dust, and we advocate that all safety precautions, safety PPE, be used as if you were doing any blasting job if you're using our material. But as far as disposing of the abrasive and those other safety issues and environmental issues, as long as the abrasive is not contaminated with hazardous materials from the coating that was removed or the surface it's being treated, as long as it's not contaminated, you can safely let it be disposed of in water, on the ground, or dispose of it by conventional methods. But it's there's no danger in the material itself.
Thank you, Steve. So we've got a question about specifically EpiX. How can EpiX outperform harder abrasives like aluminum oxide, and you even state silicon carbide, when EpiX is a lower hardness from what I understand? Go ahead.
Yes. So it's a generally accepted fact in the world of surface preparation that harder abrasives tend to be more aggressive, tend to be able to blast faster than abrasives that aren't as hard. And that is true. We're not denying that. This is one of the counterintuitive effects that we had to get our heads around because it was happening. We have gone into aluminum oxide applications many times now, and we have encountered alumina zirconia. We have encountered silicon carbide, as we showed you in the presentation, and we are going faster, and we are leaving a cleaner surface. And the reason is that energy delivery. The other particles, other abrasive particles that are not produced in a controlled environment have weak planes in them where they tend to break. And now, silicon carbide doesn't break as much as, say, a slag or crushed glass would. It's not nearly as friable. But what we're finding is that it does not deliver as much energy to a surface as our superoxalloy does. And we're seeing it all the time. We've come to expect it.
So we have a question on running at about 90 psi at the nozzle, and if that's enough pressure. And then we have another question that's related to blasting specifically with the 10X product. What would you choose 10X product-wise for a 3 to 4 mil profile on new construction aluminum vessels? And I know I threw two questions at you once. Sorry about that.
Oh, that's okay. The first one was, what was the first question?
90 psi at the nozzle. They're asking
90 psi, yes.
Pressure.
So the answer is yes. You'll do just fine. You probably even see an improvement, but you won't see anywhere near the improvement as if you could get it up over 110 psi at the nozzle. But yes, the abrasive is effective at 90 psi. It just really comes alive at the higher pressures if you can get there. And then the second question was,
what would we recommend for a 3 to 4 mil profile on new construction aluminum vessels?
So, aluminum is softer, but I would say that you're probably in 40-70, possibly 20-70, but it would be the finer fractions of the Kinetics product line.
Thank you, Steve. And then we have how many cycles can Kinetics be recycled in the field?
Yeah, that's what we talked about that a few minutes ago. You can expect anywhere from 3 to 6 times, depending on the blasting conditions.
All right, and I'm just going down the list here. There's another question specifically about the density of the product and how it can deliver more energy. Essentially, I think there's a confusion between density and energy delivery. If you could explain how they're not the same with 10X.
So, no, I mean, assuming the particles are coming out of the nozzle at the same speed, if we assume that, two abrasives, one less dense, one more dense, then the one that has more mass, the denser abrasive, will have more energy to deliver to that surface. Energy is 1/2 mv squared, mass times velocity squared. But now, when those particles arrive at the surface, even though the more dense particle arrives with more energy, if that particle breaks, if it's more friable, if it's an abrasive that produces more dust, then that extra energy is lost when the particle breaks. So that particle's energy, part of it was used to do what it did to the surface, and part of its energy was used in breaking. If the 10X particle doesn't break, even though it had less to begin with, it can deliver more to the surface because it didn't lose its energy in a break. And that is, if there's a key to this superoxalloy category, it is that. It is all about the ability to deliver the energy of the particle efficiently to the surface, and that's how it can perform better than a denser abrasive, or a harder abrasive, or a sharper abrasive.
Thank you, Steve. So I'm going to answer this next question, and then I'll flip it back to you, and that'll probably have to be our last one. The question was, how quickly can 10X ship products of substantial orders of 200 to 300 tons? Frankly, if you put an order in by or before 11 a.m. Eastern, typically we can ship same day, so long as we can get a truck. If not, it'll be next day. 10X is a manufacturer, but we have a large warehouse, and our distributors also stock the product. So between 10X's inventory and our distributors, you have far more than that amount. 10 of you could order that amount, and we could respond to that, in less than 24 hours, provided trucking availability. And for less than truckload orders, they're almost always going to ship same day. It's a trucking availability with COVID has been a little bit more challenging lately, so we still like to give ourselves 24 hours. But yeah, no problem responding to that. And Steve, there was also a question here. Let me just scroll back down. It scrolled up on me, sorry. Are the products available nationwide? Yes. PPG is a distributor with nationwide and really global presence. They're a 10X distributor. They have stock in multiple locations. We also have MES on with us. We have multiple distributors. They're listed on our website. You can see it there. And there's a question about, sorry, let me just get back here. I apologize, everybody. I think we already answered this one. So this is an interesting one, and Steve, you'll have to be a little quick on this answer. We might want to take this offline to answer more detail, but somebody's asking, how long does the product last in a given pot? Will I be refilling my pot more? And I mean, that's fairly easy to answer. That's one of the big advantages that we offer, in my opinion. But go ahead, Steve.
Yeah, so because of the lower consumption, there will be fewer pot changes, and we're seeing it's all over the map. We try our best to set everything for our customers at the minimum possible consumption where they're productive. So it varies, but to say that a pot will last 50% longer is not a stretch, and we've had it last longer than that compared to other abrasives.
All right, thank you, Steve. So before I turn it back over, I just want to remind everybody that there is a special offer available for people who are on this webinar or signed up for it. If you order any of the EpiX products in the next 48 hours, we're offering completely free shipping for delivery within the continental United States. We also offer on-site customer support for anybody who requests a demo. Contact us or any of our distributors, and we're happy to set up a demo and fulfill those. And of course, social distance and mask wearing, all of that, safety precautions are going to be followed. And just a last reminder, tomorrow there's going to be that live socially distanced outdoor demonstration, 10X Superoxallloy, at the Plaquemine Point Shipyard, which is right outside of Baton Rouge, Louisiana. That's courtesy of Cleaner Blast. Go ahead and reach out to 10X or Cleaner Blast if you want to participate in that, and we will have videos of that. There's also going to be a video coming out with Greener Blast. Actually, I think it's out, but it'll be available on our YouTube channel, where you can see the same product on live demo as well. And that concludes the question and answer piece of this presentation. So thank you, Steve. Thank you, Stephanie. I'll hand it back to you now, Stephanie.
Yep, thank you, Jake. Thank you, Dr. Ritchie, for sharing some of your time and knowledge with our attendees. And thank you to everyone else for joining us in today's webcast called New Category of Blast Abrasives from 10X Engineered Materials. As a reminder, this webcast will be available on demand in about 24 hours and will be accessible then. And as always, happy coding.